Hey guys, we're gonna go over today is the lesson over properties of exponential expressions, exponential functions. So let's go ahead and get started right now. Now the first property that we want to go over is multiplying exponents. So when multiplying like exponents, you add the exponents. So the example we have right here is a to the n times a to the m. What you want to do is take n and m, add those two together. Okay, so for example, this is what we have: 7 to the 5th power times 7 to the 8th power times 7. Now when you see that, that should actually be a 1. Example of a 1 right here. Okay, so all you're going to do is take all those three exponents because they have like basis. This case right here, our 7 is our basis, so whatever the exponents sit on, that's your base. You're going to take those three exponents, add those together, and you're left with 7 to the 14th power. Now, you guys try this last one. Yes, you're correct. Now we're just going to take our two exponents, 6 and 4, because we have like basis, which is 4 and 4. 4, 6 plus 4, which is going to give me 4 to the 10th power. Okay? So yes, all you're doing is when you're multiplying like basis, you want to add your exponents. There we go. Now let's move to the next one. Now we're raising a power to a power. Okay? When you then you're going to multiply the exponents. Now, example of power to a power. So when you have something set up like this, you have the exponent sitting on the outside of the parentheses. Okay, no basis, just one base. You're going to take those two exponents and multiply them. The example that we have for this is 2 to the 5th raised to the 3rd power. So now it's a power to a power. So we're going to take these two and do what? Multiply them. And now we're left with 2 to the 15th power. Okay? Now, you guys try. Same example, all we're going to do is take 3 and 5, raising a power to a power, multiply those two exponents. Now we're left with 4 to the 15th power. Now we have negative exponents. So in this case, we're talking about a -1. Now any integer raised to -1 is the reciprocal of that integer. Now we talked about this a little bit. All it means, guys, when you hear reciprocal is to flip. So you want to flip whatever number you have. For example, we have a to the -1. You just want to take a to the -1 and flip it. That means you're going to put 1 in your numerator and put whatever that base is in your denominator. Okay, let's look at an example. 3 to the -1. Just as easy as that. You put 1 at the top in your numerator, put 3 to the 1st power in your denominator. Just that simple and easy. Now you guys try. 15 to the -1. All we're going to do is take that 15, the base, okay? Put that base at the bottom. Take this 1, put it at the top. That's our answer. Just that simple and easy. Just that simple and easy, guys. Now let's say we don't have a whole number anymore. Let's say we have a fraction, okay? Any fraction raised to -1, so still negative exponent. You're going to find the reciprocal. Now remember I said reciprocal means to flip. So you're going to take whatever fraction that you have and flip it. Right here you have a over b to the -1 power. You just take it, flip it, b over a. For example, 2 over 5 to the -1 power. All you do is flip it, which is the reciprocal. Now you guys try. What would that answer be? We know all we're going to do is we have a negative exponent. So let's take 15, put at the top, 9, put in the denominator, And the answer is 15 over 9. Great job. So guys, the next rule we want to go over is when we're dividing exponents. Again, we'll look at them having the same like basis. Okay. So for example, we have a to the n, divided by a to the m. All you do is take both of your exponents and subtract them. So you want to keep the top exponent first, subtract it by your bottom exponent, which is the denominator. Go ahead and subtract those, and it's just that simple and easy. So let's look at our example. Okay, we have x to the fifth divided by x to the third. We're looking at both of our bases. Are our bases the same? Yes, they are. So now you're going to take your exponents and give you 5 minus 3. 5 minus 3 gives us 2. So we know that what? Our answer after this is x to the second power. Okay? So now, let's look. You guys try your example. Okay? Yes, now we know all we're going to do is take x, same basis, take x, our first exponent, which is 12, subtract that by 4. 12 minus 4 should give us 8. So we know our answer in this one should be x to the 8th. Okay, let me go ahead. There we go. Okay, good job, guys. Good job. All right, only 2 more slides to go, guys. Only 2 more slides to go. So any number raised to the first power is itself. We talked about this yesterday, and you guys already know this. A to the first power is A. I'm going to go through this pretty quickly. 3 to the first power is itself. This answer right here, okay, 5,200. Oh, all right, got tongue twisted. 500,028 and 921 to the first power. We know anything about that, it will be itself. So that's your answer. Good job, guys. Okay, so our next slide. Any number raised to the 0 power is 1. Again, that's another power that we talked about yesterday. Anything raised to the 0 power is 1. So in this case right here, 3 to the 0 power is 1. All right, now you try. Just as simple and easy. Anything raised to the 0 power. So how big a number is, it's always going to be 1. Boom. That's our answer. All right. Great job, guys. What you guys are going to do is you're going to go ahead and work on those examples that I just passed out. So go ahead and ask me for that.